Hi, my name is Jake Guerin. I'm a second-year master's student studying sedimentology and stratigraphy at the University of Texas at Austin. I am one of the developers of LakePy. I was PI on the grant, and it was developed with my collaborator, John Franey, who is another second-year master's student with the Gulf Coast Carbon Center here at UT Austin. Okay, so what is LakePy? So the basic idea behind LakePy is that lake level data is hard to get. It's not impossible to get, but it's scattered. It's in a lot of different databases. Some of the organizations that keep lake level data, these systems were developed a few years ago, so a lot of time it's text based, CSV, flat file based. So kind of what I and John thought is that we could do this in more of kind of an updated way that would serve updated lake levels easily, so through an API or Pythonically. So the database consists of the USGS National Water Information System, so all the lakes in the US that they record, the USDA's Foreign Agricultural Services GREALM database, which tracks global lakes, and then THEA, which is a French organization, their HydroWeb database, which similarly tracks global lakes. So, like I said, or I probably didn't say yet, funding for this work came from the Winter 2020 grant, so that's wrapping up. And so kind of part of that is here, giving a demo. You can see the funded proposal on our documentation page. So this was mainly done using Python and just Amazon Web Services. And so let's get started. So I'm going to be walking through this Jupyter notebook called, funnily enough, LakePy Walkthrough. That can be found if you go to ESIP Fed, LakePy, or you can just Google LakePy. You can go to the notebook section, and then LakePy Walkthrough is right there. But I have it up here, so let's just kind of go through here. Okay, so the first thing we would want to do if we have a lake in mind and we want to get some data from it is we would import LakePy. We do it as LK, kind of if you know Python, you just abbreviate it to make it easier. Okay, so let's say if we wanted to find Lake Mead. So we do the search by specifying the name, right? So lk.search, and we specify the name. You can specify a name, an ID number, or a source. So just that's for you, but in generally most people when they're doing exploratory searching will just be using the name. So what that turns out is two lakes. We can see LakePy gave a warning saying that Mead has more than one result. If you want to get data, you're going to have to specify the ID number or somehow else narrow the search name. So which one of these do we want? Well, I was thinking Lake Mead in southern Nevada. I think that's probably not the Mead Lake West Bay near Willard, Wisconsin. So we're going to go with this first one from HydroWeb with the ID number 114. So then I'm going to kind of redo the search I could have done it up here, but just for linearity. So redo the search using the ID number, and we see this nice data frame of metadata that pops out showing us the lake name, where it's the source it comes from, basin status. Those come directly from HydroWeb, so they won't be available in other lakes per se, but everyone should have a start date and end date to the coverage, kind of the country of residence, and some simple things like lat long. Okay, so now what, right? So this pops out, okay, well and good, we have our Lake Mead. Well, now Mead, this variable, is a lake object. So kind of similar if you work with Python or Pandas, you do, data frame equals pd read CSV or something like that, my CSV.csv. So kind of similar, and now, df or the data frame would have certain things. So you could do, df median. You could do all these sorts of things. So similarly, Mead has a lot of attributes and methods, which we'll go into. So you can do something as simple as get the metadata from Mead. This is the same output as the search function. Or you can directly get the observation period, lat long, country, what have you. And then the actual data is housed in the mead dot, or the lake object, which is mead.data. So we can see here that all the data is downloaded. This is only 119 rows, but if you had 7,000 rows of data, there'd be 7,000 there. And what's really good about this is it has a bunch of associated. This is a pandas data frame, and so you can do things like take the median. Right, so okay, our median water level is 342. You can filter the data set, or what's even better is you can save it to a CSV if you wanted to, test.csv. And that's really nice because now if we go back out here, oh, there it is, all our data. So you have a lot of nice methods. The other thing you have is or I should say you have a lot of, the other thing you have directly in LakePy is the map view, the plot map view, and the plot time series methods. So plot map view just kind of simply uses these two Python packages, GeoPandas and ContextIly, to kind of plot these simple overview maps. They should really only be used to check if the lake that you want is actually the correct lake. If you're really looking for some intense remote sensing stuff, I would download a shapefile or something like that and work with that on your own in a program like QGIS, ArcGIS, for example. The big thing here, and I think the most what will probably be the most used function is the time series plotting. So if we run this, we open a different window that's run by Plotly on our local host. And you have this really nice graph that's stretchable. You can filter it however you want. And so this is going to be really good for kind of end users that don't have a lot of coding experience. Otherwise, of course, you can specify matplotlib or seaborn if you want to kind of use those plotting functions. And what you can even do is set show equal to false and then set this equal to our axis so that you can actually do something with the axis. So we could set the x limit, or we could set the y limit, to be, 340 to 350. And so you can directly operate on the plotting axis there. So that's kind of it. That's kind of the general overview. It really should make it easy to get data. Of course, you can search anything in here. You could do something as simple as Tahoe, just to stay in the west, or you could do something really general like pond. That's going to turn up a lot of stuff, so you need to be somewhat specific. The other thing you can do is go to our GitHub and click on the lake reference list. You can kind of just do a Control F search if you want and get the ID number. Okay, so that's it. I hope you guys all enjoy, and thank you.